Okay, hey everybody, let's get started. So today we're going to start with section 2.3. Let's go through some of those problems. The section is pretty similar to section 2.2. In 2.2, we're talking about combination functions. In this section, we're talking about something called a composition function. All right, and so how we write a composition function is like this: f, and then a little circle, and then a g. And here I guess we can just write, so f of x and g of x are functions. So any function, x squared, x squared plus 3, doesn't really matter. Anyway, so let's move this down a little bit. And this circle does not mean multiplication, so it's not f times g. So what this means is that we're plugging g inside of f. Another way of writing that is, so we have f, and the thing that we're plugging inside of f is going to be g of x. So like a quick little example, say if f of x was x squared plus x plus 3, and then g of x was equal to 2 minus 3x. Say if we wanted to find f composed with g of x. From the definition, all that means is we're plugging g, the thing on the right, we're plugging that and the thing on the left. So we're plugging g into f. So what this means is f, we're going to plug g inside of it. So remember, this thing on the inside, this is just like a placeholder. This x right here, this x, anything inside those parentheses, it just goes here, and then it goes here. So now the thing on the inside of the parentheses is this g of x. So now a g of x is going to go here, and a g of x is going to go here. So what we mean by that is we're going to have g of x squared plus g of x plus 3. You see, all we did here is just we took f of x and replaced all the x's with g of x's. So then if we simplify this a little bit, let's just put in what g of x is. So this is going to be, so g of x is 2 minus 3x. We'll have 2 minus 3x squared plus 2 minus 3x plus 3. And in the next line, if we FOILed out the 2 minus 3x squared, we would get 4 minus 12x plus 9x squared. Here we're getting a plus 2 minus 3x, and then a plus 3. And then combining all the like terms, so we have a 9x squared minus 15x. Then 4 and 2 is 6. And 3 is 9. Yeah, so then plus 9. And so this right here would equal f composed of g of x. And then we could also kind of do it the other way around. So this was f composed of g of x. We can also do g composed of f of x, so the backwards one. So g composed of f of x. So now what we're doing is we're plugging f inside of g. So this is going to be g. We're plugging f inside. So just like before, so look at when we have g of x. There's whatever goes in this parentheses, all we do is just put it here in this case. So if we plug f of x in, this is just going to equal 2 minus 3 times f of x, because we're plugging f inside of g. All right, so what does this equal? So we're going to get 2 minus 3. And what's f of x? F of x is x squared plus x plus 3, which equals 2 minus 3x squared minus 3x minus 9, which equals minus 3x squared minus 3x minus 7. Yeah. All right, and so this would be our answer for this one. And we can do maybe as one more one. We can even do something like g of x. All this means is we're plugging g inside of g now. So we take our g of x function, again, anything that goes in the parentheses, all we do is place it right here. So now we're plugging g of x inside. So this is just going to be 2 minus 3 times g of x. And that's just equal to 2 minus 3. And g of x is 2 minus 3x. So we plug a 2 minus 3x in for g of x. And this is going to equal 2 minus 6 plus 9x, which equals 9x minus 4. Okay. Let's do a different example. How about something like, we could do one from the, so I guess 1 through 16 in the book is, so this is like problems 1 through 16. So in this problem, we're given that f of x is equal to 3x plus 1. G of x is equal to x squared minus 2x minus 6. And then h of x is x cubed. So we could do 2. So 2 is telling us to find g of f of minus 2. So in order to do this, all this means is we're plugging f inside of g, and then we're evaluating it at minus 2. So this means we want to find this g of f of minus 2. Okay, so what's g? So if we look at g again, so anything that goes in the parentheses for g, we put it here, and then we put it here. So now we're plugging in f of minus 2 inside of g. So what this is going to equal is, so g is x squared minus 2x minus 6. So this is going to be f of minus 2 squared minus 2 times f of minus 2 minus 6. Okay, so what is f of minus 2? Well, f is over here. It's 3x plus 1. So this is going to equal 3 times minus 2 plus 1. That's what f of minus 2 is. So square that. Again, f of minus 2 is 3 times minus 2 plus 1. Let me subtract 6. So this is going to equal minus 6 plus 1 squared. Minus 6 plus 1. So we got minus 5 squared. Minus 5. Minus 6. So minus 5 squared is 25. Minus 2 times minus 5 is 10. And this is going to equal, so 35 minus 6, which is 29. All right, and how about what's f and h? F and h, that seems, maybe we could do that one. Let's do number 7. So number 7 is telling us to find f of h of minus 3, which is equal to f, and we're plugging in now h of minus 3. So let's go, what does f mean? Well, we look up above, f, whatever we plug inside the parentheses, all we do is we just put it right here. So now what we're plugging inside is this h of minus 3. So what this is going to equal is, so 3x plus 1, so that means we're going to have 3 h of minus 3 plus 1. So this is going to be 3. What's h? H is x cubed, so this is going to be minus 3 cubed plus 1. So this is going to be 3 times, so minus 3 cubed is minus 27 plus 1. And then minus 27 times 3, that's minus 81. And then plus 1. So this is just going to equal minus 80. All right. So let's move on to some other, what else do we got from this section? Oh, and I guess the last thing we need to talk about is domain. What questions do we have from here? To 39. Okay. So the domain of composition functions, this is very similar to when we do the domain of the combination functions. So this is, we'll like learn this through some examples. Let's start with, maybe, I don't know, 21's fine. So for 21, we want to find the domain of we'll just do one of them. Let's just do f of g of x. It's telling us to do f of g and g of f. For this one, let's just do one of them. And in this problem, we have f of x is equal to x squared minus 3. And g of x is equal to 4x minus 3. All right, so first we got to figure out what is f of g of x, and we'll find the domain of it. So to do these problems, let's just start. So we're looking for the domain of f of g of x, so we need that. So what is f of g of x? So f of g of x, this just means f, plug g of x on the inside. Again, so if we take f of x, anything that goes inside these parentheses, all we do is place it right here. So now we're plugging g of x inside these parentheses. So this is going to then equal g of x squared and then minus 3. All we're doing is plugging g inside of f here. And now the next step for the domain is replace the g with what it actually means. So here g means 4x minus 3. So we're going to do that. This is then going to equal 4x minus 3 squared minus 3. And then when we're asking for domain for these problems, we stop right here. We don't do any more simplifying. So we find the domain of this. The second we plug in the f and the g, or once we like kind of once we plug in the g here, and we're at this step, this is the part we're going to find the domain of. So we're not going to simplify. One, because if we do simplify, we might get the wrong answer. And two, because this problem is only asking for the domain, so there's no reason to spend more time and do the work to simplify when we don't need to. But regardless of that second point, you'll get there are some situations which we'll go over, like for example, like problem number probably 25. We'll do that one next. If you do simplify, you'll get the wrong answer. So we need to find the domain of this, which is the unsimplified version. So again, for domain, we always ask the two same. Sometimes the simplifying doesn't change it. You'll get the same answer. This is an example where you would, but there are situations where you won't. But regardless, so when we do domain, always we think of the same two things. Are there fractions? And are there square roots? So because those are the only times we ever have problems. And domain means we want to get rid of the problems and what are all the values that we could plug in and we don't have problems. So if you remember with fractions, we can't divide by 0. And with square roots, we can't have a negative number inside of them. So with fractions, so the answer to this question, do we see any fractions? So we're looking right here. Do we see any fractions? That answer is no. And do we see any square roots? That answer is no. And like we said, maybe in one of the previous videos, whenever we have no fractions and no square roots, the domain is going to be all real numbers. So our domain here, because there's no fractions and square roots, it's going to be every number. So minus infinity all the way up to infinity. All right, how about, let's do 23. So for this one, again, we just want to find the domain. Of f of g of x. And here we have f of x is equal to 4 over 1 minus 5x. And g of x is equal to 1 over x. All right, so now let's find the domain. So again, what does f of g of x mean? This means we're going to take g and we're plugging it inside of f. And again, so what does f of x mean? Well, whatever we plug inside these parentheses, all we do is we just plug it in right here. But now the thing that we're plugging in is this g of x. So let's just plug that g of x in right there. So this is going to be 4, 1 minus 5, g of x. And so what's g of x? That's 1 over x. So this is going to equal 4 over 1 minus 5 times 1 over x. Actually, let's write that as 5 divided by x. Okay, and so now we stop. There's no more simplifying. Because if we do simplify at this point, we're going to get the wrong answer. And we don't need to because we only need to find the domain. So regardless, once we plug in our function like this, we stop here. Now we're going to find the domain. So with domain, two things. Are there fractions? And are there square roots? So fractions, yes. Square roots, no. So we have to do some work with fractions. So if we remember what's the thing with fractions is that we can't have the bottom of the fraction being 0. So where do we see our fraction here? Well, this whole entire thing's a fraction. And here's the bottom of the fraction, 1 minus 5 over x. So 1 minus 5 over x, this is not allowed to be 0. Okay, but again, there's another fraction. Just in the bottom itself, there's a fraction right here. The bottom of that fraction is x. So we also have to have x can't be 0. So those two things need to, we need these two conditions because we have, this takes care of all the fractions. So what happens in this left equation? Well, let's solve for that. So we can add the 5 over x over. So we're going to have 1 can't equal 5 over x, just from adding 5 over x to the other side. Then we multiply x on both sides. So we get x can't equal 5. All right, and then over, so this is something that we need and nothing to do here, just x can't equal 0. So we go to our number line. Here's 0, here's 5. Can't be these numbers, so we put circles on them. And again, that's the only situation that has a problem. The square roots, or there's no square roots, so we can't do anything there. So the only issues are 0 and 5. So we get rid of those numbers and we shade everything in the middle. Then we shade everything on the left and then everything on the right. So then our domain is going to be minus infinity up to 0. And we're using parentheses because of the open circles. Then 0 to 5. And then 5 to infinity. All right. How about maybe 27 or 28? Let's do 28. So we're going to find the domain of, let's do g of f of x. So find okay, so find the domain of g of f of x, and here f of x is equal to square root of x, and g of x is equal to 2 minus 3x. So first thing to do, let's just figure out what does f of g of x equal, or sorry, g of f, what does g of f of x equal? So g of f of x, this is g, and we're plugging in f of x on the inside. So with g, just whatever goes inside here, we place right here. So now the thing that we're plugging on the inside is going to be this f of x. So this is going to equal 2 minus 3 times f of x. And that is going to equal 2 minus 3 times, and f of x is square root of x, so square root of x. Okay, so then we stop right here. Now we look for the domain. So again, so are there fractions and are there square roots? So the answer to fractions is no, we don't see any fractions over here, but we do see a square root. And so if you remember, we always have to have the inside of our square root being bigger than or equal to 0. In this situation, our inside of our square root is just x. So the only thing we need is x to be bigger than or equal to 0. And so this is the only condition we need for our domain. So we go over here, 0, put a closed dot on there, and bigger than 0, so it means we shade over to the right. And so we're going to get 0 up to infinity. Let's do 33. So let's do f of g. So find the domain of f of g of x. So find the domain of f of g of x, and in this problem we have f of x is equal to x squared plus 2. So f of x is equal to x squared plus 2. And then g of x is going to be equal to square root of 3 minus x. So just like before, the first step is let's just figure out what does f of g of x equal. So we write this down. So f of g of x, f, we're plugging g of x on the inside. So with f, whatever we plug inside of our inside of f, all that does is just goes right here. So now the thing that we're plugging in is this, the g of x. So this is going to equal g of x squared plus 2. And then g of x is the square root of 3 minus x. So this is going to be the square root of 3 minus x squared plus 2. And then we stop right here. So normally we could simplify, if we square a square root, this just goes away. So we could write this like 3 minus x plus 2. But if we do that, we're going to get the wrong answer when finding the domain. So we don't do any simplifying. Once we plug in our function, we stop right there and we find the domain. So for this one, again, are there fractions? Are there square roots? So no fractions here. So no, setting the bottoms equal to 0 because there are no bottoms. There's no fractions. Square roots, yes. So the inside of our square root here is 3 minus x. So what we need for this problem is we need 3 minus x to be bigger than or equal to 0. And if we add the x over, this just tells us we need x to be less than or equal to 3. So we go to our number line. Here's 3. Closed dot because it has that or equal to sign. And it's saying x has to be less than 3. So we shade over to the left. So our domain for this problem, minus infinity up to 3. Okay, what else from this section? We could do number 36. So let's find the domain of g of f of x. Of g composed with f of x. And here f of x is equal to number 36, 1 over x minus 2. And g of x is equal to x plus 2 over x. All right, so first thing, let's just figure out what is g of f of x equal to. So g of f of x, this is equal to g of f of x. And just like before, so g, so whenever we plug anything into g, it goes here, and then it goes here. So now the thing that we're plugging in is the f of x. So this is going to equal f of x plus 2 divided by f of x. So what does that equal? So f of x, that's 1 over x minus 2. So we'll have 1 over x minus 2 plus 2, all divided by f of x, all divided by 1 over x minus 2. Okay, so let's see. Are there fractions and are there square roots? Fractions, yes. We see several of those. Square roots, no. So the fractions, what do we see? Well, this entire thing's a fraction. Here's the bottom of that fraction. So we have to have 1 over x minus 2. This is not allowed to be 0. Okay, so what about if we just look at the bottom itself? Here's a fraction. The bottom of that fraction is x minus 2. So x minus 2 can't be 0. And if we look at are there any more fractions? There's one more fraction. It's the same thing. Here's a fraction up here. The bottom of that fraction is also x minus 2. So again, we can't have x minus 2 being 0. So really those last two things mean the same thing. We're just writing it to kind of show all the details. But these two things, those are the same thing. Anyway, so let's see what happens when we solve for this left one over here. Notice right off the bat, so what we could do is, if we're trying to solve this one on the left, this guy, if we multiply both sides by x minus 2, so x minus 2, x minus 2, what happens is it cancels on the left-hand side. We just have a 1. But over here, we have 0 times x minus 2, which is 0. So over here, we get that 1 can't be equal to 0, but 1 is never equal to 0. Let's put a line here dividing it. So we don't really, from this, we can just say, like, we have a number that's equal to a number that's not itself. This just tells us that there's no solution for this part. Or in other words, 1 over x minus 2 is never equal to 0. So there's nothing to worry about here. We could plug in any x value we want, and this thing is never going to be equal to 0. So there's nothing to really worry about that one. So let's move on to the next one. This is just saying x minus 2 can't be 0. So this is telling us that x can't equal 2. So that's okay. That gives us some information. And same thing over here. We just get that x can't equal 2. So really the only problem is going to be at 2. So our domain, here's 2. Get rid of it. But everything to the right's okay, and everything to the left is okay. And so our domain for this one, minus infinity to 2, and then 2 to infinity. All right. Let's do one more. Let's do like, we could do 42. So what this problem is giving us is it's saying that h of x is equal to 1 divided by the square root of 3x plus 7. And what we want to do here is find a f of x and g of x such that f composed of g of x is equal to h of x. So there's several answers for this problem. Remember, let's talk about a couple of them. So for this problem, what we could do is we could define, let's say here's solution 1. If we define f of x to equal 1 over x, and then let's define g of x to equal to the square root of 3x plus 7. So notice in this problem that if we found f of g of x, this is going to equal. So what does this mean? Well, this means that we're plugging g inside of f. And then, well, what is f? F is just whatever's inside here, you put down here. So this is actually just going to equal 1 divided by g of x. But g of x is the square root of 3x plus 7. So actually this just equals 1 over the square root of 3x plus 7. But that's what h of x was equal to. All right, so that's one possible, this is one possible solution. F of x is equal to 1 over x. G of x is equal to the square root of 3x plus 7. We can do another solution to this one as well. We could let f of x be equal to 1 divided by the square root of x. And g of x is going to be equal to 3x plus 7. All right, so then what does f compose with g of x? This is f of g of x. So f of x is 1 divided by the square root of x. So this is just going to be 1 divided by the square root of g of x. But g of x, that's 3x plus 7. So this is 1 divided by the square root 3x plus 7. And again, that's the same thing as h of x. So here's another solution. Maybe we just do one more together. What we could do is this one's sort of like a, actually, let's just leave it at these two. This sort of like illustrates the idea. These are probably the two most obvious ones to do. That would make the most sense. But yeah, the thing is that there's more than one answer for these ones. Okay, I think that's actually good for this section. We had to go up to 39. Yeah, we did that. Okay, let's move on to section 4.4. What do we start with here? 15. All right. First, let's just talk about what does it mean symmetrically to be. Sorry, let me look something up real quick. Actually, that's not too important. Let's just talk about two types of symmetry real quick, just with pictures of graphs. So if we have a graph like this, here is our x-axis, here's our y-axis. Maybe the graph looks like this. So here the y-axis is acting like a mirror image. So here this graph, let's call this graph g of x. G of x is symmetric across the y-axis. It just means that the y-axis is like a mirror image. Whatever happens on the right happens on the left. And then say if we say something along, let's draw another set of, we have a y-axis here, an x-axis here, maybe something like this. So here, let's call this one f of x. So f of x is symmetric across the x-axis. Okay, so all that basically means is that the x-axis is like a mirror image. So these are like two types of symmetry. So if you're given a graph and I ask you which one's across the y, which one's across the x, you have, this is just sort of like your two little, things. If it's a mirror image on both sides of the y, it's symmetric across the y. If it's a mirror image across the x, then just whatever happens on the top of the x-axis happens on the bottom. Determine whether, oh, okay. So now let's mathematically, so if we're not given a graph, if we're just given a function, how do we figure this out? So how to determine symmetry without a graph. So we only drew two types of symmetry up here. There's three types. So there's another one across the origin, which we don't really need to draw. This top part is just sort of like a little explanation. All that really matters is the stuff down here, like determining it without a graph. So say if we're given, let's talk about across the x-axis first. Let's say if we're talking about the function f of x. So let's say, so how to determine symmetry. Let's put of f of x. Without a graph. So if you're symmetric across the x-axis, what this means is that, no, sorry, let me look this up. I think it's f of x has to equal minus f of x. Yeah. Oh, wait. No, not that one. Where are we at? Right. So you're symmetric across the x-axis if f of x is equal to minus f of x. Or, sorry, let me think about this for a second. That is, sorry, we need to actually not say it like this. We need to write this as, how do we say this? We can't actually talk about a function in this situation. What we're going to say right now is, so say if we're symmetric across the x-axis, what this means is, we'll do this with an example in a second. If we, this is what the definition would be for this. So if we replace, sorry, one second, this doesn't make any sense. Yeah, so if we replace y with minus y, and the resulting function does not change. This will make sense in a second when we do examples. And then, so across the y-axis, is if we replace x with minus x, and the resulting function doesn't change. Okay, and then across the origin, this is, I believe, if we do both of those, x minus x, yeah. If we replace x with minus x and y with minus y, and the resulting function does not change. Okay, so these are the three conditions. So let's do some examples with these ones. So this is going to be kind of like from 15 through 26. So let's start with, how about number 15? So we want to know, so for the following, or let's say, state the type of symmetry for the following. Okay, number 15, that is, so the equation that we're given is 5x minus 5y is equal to 0. All right, so let's see if this has any type of symmetry. So it's either going to be 1, 2, or 3, or neither. So either across the x, across the y, across the origin, or it's going to be neither. So let's test the x-axis. The x-axis says we need to, if we go back up here, we need to replace y with minus y. Okay, so so we have our equation 5x minus 5y is equal to 0. What happens if we replace y with minus y? Well, we have 5x minus 5 times minus y is equal to 0, which is 5x plus 5y is equal to 0. So notice how it says up here, if we replace y with minus y, so this is what we're looking at, if we replace y with minus y, and the function does not change. However, when we replaced y with minus y, the function did change. See, this is 5x plus y is equal to 0. Here we have 5x minus 5y is equal to 0. So these are two different things. So this thing right here, not the same. So it's not symmetric across the x-axis. All right, so now let's test the y-axis. So the y-axis says we replace x with minus x and see if the function changes or not. So this is going to be 5 minus x minus 5y is equal to 0, which is minus 5x minus 5y is equal to 0. We could factor out a minus sign. So this is minus 5x plus 5y, which is equal to 0, which if we divide by that minus sign, we just have 5x plus 5y is equal to 0. And this piece right here, this is not the same as the original function. The original function was 5x minus 5y. This is 5x plus 5y. So it's not symmetric across the y-axis either. Okay, so not symmetric across the x, not symmetric across the y. All right, let's try the last one, the origin. All right, so this is telling us replace x with minus x and y with minus y and see what happens. So we're going to have 5 minus x minus 5 minus y is equal to 0. So all we did here is just replace in this part of this problem, We replace the x with minus x, the y with minus y. Now let's simplify and see what happens. So we get minus 5x. Here we have a minus minus, that turns into a plus 5y. But now notice, say if we multiply both sides by a negative number. So let's do -1 on the left-hand side, multiply by -1 on the right-hand side. What we get is 5x minus 5y is equal to 0. So it's the same thing. So this tells us that since we replaced x with minus x and y with minus y and the function didn't change, our function right here is symmetric across the, so this function is symmetric across the origin. All right, let's do one more like that. How about 20? So here we are given that y cubed is equal to 2x squared. All right, now let's see what type of symmetry this thing has. So for the x-axis, we replace y with minus y and see if anything changes. So we're going to have minus y cubed, 2x squared. Minus y cubed is minus y cubed. If we use a cube of minus, the minus still stays. So this equals 2x squared. But this is not the same function. Before we had y cubed equals 2x squared. Now we have minus y cubed equals 2x squared. So not the same. So this is not symmetric across the x-axis. All right, now let's do y-axis. So the y-axis is replace the x's with minus x's. So we're going to get y cubed is equal to 2 times minus x squared. And if we simplify this, we'll get y cubed is equal to 2. And if we square a negative, it goes away, so it is 2x squared. And now we see this function is the same thing. So it is symmetric across the y-axis. And then the last one, let's see if it's also symmetric across the origin. So if we replace the y with a minus y, the x with a minus x, so what we end up getting is minus y cubed is 2x squared, which is not the same thing. And so here, this thing, not the same thing, so it's not symmetric across the origin. Okay, so last thing from this section, which is sort of the same thing as what we just did right now. Talking about what is an even function or an odd function. So even functions and odd functions, let's say the definition of an even function. So an even function is if f of x is equal to f of negative x. So if we replace x's with minus x's, the same thing, we're even. An odd function is if f of x is equal to minus f of minus x. So if we replace, just put a minus in front, replace the x's with minus x's, if they're the same thing, then it's an odd function. And then we can be neither, so you don't have to be either one of these. Neither is just if either of these things doesn't happen. All right, so let's start. What's the homework problems here? 39, 41, 45. So let's start with 40. So are the following even, odd, or neither? All right, 40. What do we got here? So f of x is equal to 7x cubed plus 4x minus 2. All right, so let's see. Well, we need to find a couple of things first. We need to find what is f of minus x and what is minus f of minus x. And we've got to see if anything is equal to one another. So we're given f of x. Let's find f of minus x. So f of minus x, that's going to be 7 minus x cubed plus 4 times minus x minus 2. So here we're keeping a negative, so the minus sign stays. So we have minus 7x. Let's not use parentheses. Then minus 4x minus 2. Okay. But if we look at f of x and we look at f of minus x, so this is not the same thing. This does not equal f of x. So we know that's not going to be even. Because if it was even, f of x has to equal minus f of x. Or sorry, f of minus x has to equal f of x. So we just calculated. So here we have f of minus x. Here we have f of x. Those two things are not the same thing, so it's not going to be even. So the last thing to calculate is minus f of minus x. So we just found f of minus x. Now let's put a minus in front of it. So minus f of minus x. This is going to equal minus, and we'll plug f of minus x on the inside, which is this piece right here. And so this is going to equal, we'll have a 7x cubed, a positive 4x, and a positive 2. This thing also, this does not equal f of x. So it's also not going to be odd. So this function is not odd, it's not f, so f is, it's neither. But all we need to say, it's not even, it's not odd. Okay, how about 40 or 42? So we have f of x is equal to x plus 1 over x. Okay, so here's f of x. Let's find what is f of minus x. This is going to equal minus x plus 1 over minus x, which equals minus x minus 1 over x. We could factor out a minus sign here. So this is going to be minus x plus 1 over x. However, this is not the same thing as f of x. So it's not going to be even. Okay, but what about odd? So to do that, we have to figure out what is minus f of minus x. Minus f of minus x minus. So we have to take minus f of minus x. We just found f of minus x. F of minus x is this piece right here. So we have to take the negative of that. Negative of negative x plus 1 over x. And so now those minuses cancel. So we're just left with x plus 1 over x. But we see this is the same thing as f of x. So our function is going to be odd. Okay, how about we do one more together? We can do 48. So f of x is equal to the square root of x squared plus 1. So let's see, what is f of minus x? So we have minus x squared plus 1. But here we're squaring a negative, so it goes away. So this is just going to be the square root of x squared plus 1, which is the same thing as f of x. So we are even. Okay, so now let's see if it's also an odd function. So for that, we have to take the minus f of minus x. This is just going to be minus f of minus x we found right here. So minus square root of x squared plus 1. But that is not the same thing as f of x. So it's not going to be odd. All right. I think that actually takes care of everything that we need to talk about. So that's basically everything from section 2.4 and 2.5. Or sorry, 2.3 and 2.4. Yeah, so we'll start, the next bit of chapter 2 next week. So anyway, yeah, enjoy your weekend, and yeah, feel free to email me if anyone has any questions or anything. Cool. All right. Thank you.